Hey kiddos, today we're going to be talking about graphing linear inequalities. So unlike the last type of graphing we did where we were putting the inequalities on a number line, what we're going to do today is more like y equals mx plus b, except we're going to be replacing the equal sign with an inequality. Okay, so just a couple things that we have to talk about. So when we graph inequalities, things are going to look just a little different. Okay, so here's what an inequality looks like when you graph it, right? Again, so we're replacing the equal sign with an inequality. So we're used to graphing y equals mx plus b, so something like this where we have y equals 5x plus 3. Today what we're going to do is we're going to take that equal sign out and we're going to replace it with an inequality. Now, just like when we're finding a solution to an inequality, if I ask you to give me all the numbers that are less than 5, right, it's not just one option, right? It's not 4 or 2 or -8, it's all of those. So just like solving an inequality, when we graph a linear inequality, we're going to get something that looks a little bit different because we have multiple different solutions. Okay, so this is what the graphs are going to end up looking like. So the first thing you'll notice, there's a couple differences here with the graph. The line sometimes looks a little different. You'll notice that we have a dotted line here. So here, you have this dashed or dotted line. And so we're going to have to talk about how do I know when that occurs. And then you'll also notice that we have these areas here and here that are shaded. And so we have to talk about how do I know where the areas are shaded. So here are the two main differences when we graph inequalities. These are what we're going to be talking about today. So the two main differences are, what does the line look like when you actually graph the linear inequality? Is it going to be a dotted line, or are there times where we have a solid line? And then the second thing is, where do I shade? Am I going to shade on top of the line or below the line? Okay, so let's talk first about our dotted or solid line. So there's a couple different reasons or ways that you can recognize dotted or solid line. The easiest thing to remember is that the dotted line is basically the assumption that the line is not part of the solution. It's a lot like when you have an open dot. Okay, so a dotted line is basically symbolizing that even though we can see the line there, it's not actually part of the solution. The solid line means that the line is actually part of the solution. So what we're doing to determine if the line is solid or dotted is looking at the inequality itself. So if your inequality is greater than or less than, then it's going to be a dotted line. And then if your inequality is greater than or equal to, or less than or equal to, it's a solid line. So essentially what I tell my students is just think, if there is an or equals to symbol, if you have the little line underneath your inequality, then the line's solid, otherwise it's dotted. And again, all that means is either the line is part of the solution or the line is not part of the solution. Okay? And it's really easy to tell. Again, you just look at the inequality itself. So for example, on this first problem, when I look at this inequality, I see that it's greater than or equal to, so that is going to be a solid line when I go to graph it. And then number two, I look at the inequality, which is just greater than. There is no or equals to symbol. It's just greater than. So I'm going to have a dotted line when I go to graph this one. Okay. Looking at the next consideration we have to make. Where do I shade the graph? Above the line or below the line? So again, this is the concept of inequalities containing multiple solutions. So basically what we're looking for when we graph a linear inequality are all the points that satisfy the inequality. So we're looking for every single point that will make the inequality true. So we're not just going to have one point or the collection of points that form the line. We're going to have every point in the region either above or below the line, sometimes including the line, that will satisfy the inequality. So that's why we shade. We're shading because all of the points that are in that area where we shade will make the inequality work. Okay? Now, the easiest way to think about this is to think of more than the line or greater than the line and then less than the line. So the gray area here, right, that is the bottom of the line. We're shading on the bottom. and we could say that this whole area is less than the value of the line. We know that because it contains all of the smaller values. I'd like to tell my students that it has all the negative values included in this area, whereas this area here is shaded on the top. And again, we know that because all of these values are greater than or more than the value of the line, and it also includes the bigger values of the y-axis. So when I tell my students to either shade the bottom or the top, that's what we're thinking about. Is it below the line or above the line? What part of the y-axis does it contain? Now, when you think of it that way, it makes it really easy to understand how you determine if you're shading the top or the bottom of the graph. Again, you're looking at the inequality. If your inequality says greater than or equal to, then you're shading above, because it's literally saying that the values that will satisfy this inequality are located above the line. They're located above the line. If your inequality says less than or equal to, then you're going to shade below the line. And again, it's basically saying that the values that will satisfy this inequality are below the line. Okay, so looking at the inequality, you're either shading above or below the line based on what the inequality says. So we're going to practice now. We're going to graph a couple of these. So these are all the questions that I'm going through in my mind when I go to graph a linear inequality. So I'm looking at a couple things. Of course, I'm looking at the y-intercept to figure out where to start. I'm looking at the slope to figure out where to go. And I'm looking at the inequality to tell me if I'm shading above or below and what the line is supposed to look like. Okay, so let's first look at slope and y-intercept. So slope is 2 over 3. That means once I graph my y-intercept, I'm going up 2, and I'm going right 3. Now B is my y-intercept, so that's where I start the graph, and I'm going to start at 3, and again, that's on the y-axis. Okay. Now, looking at the inequality, I can figure out these two things right here, solid or dotted line. Looking at the inequality, we have no or equals to symbol. It's just less than. So we're going to have a dotted line. Okay. And then shading on the top or the bottom. If you look at the inequality, the closest thing to y is going to be the small pointy edge, so that means less than. So that means we're going to shade on the bottom because it's saying that y is less than the actual function of the line. Okay. Now, let's go to graph. We're going to put our first point at positive 3 on the y-axis. Now, following our slope, we're going to go up 2 spaces, and we're going to go right 3 spaces. We can repeat that one more time. Let's go up 2, and then right 3. Okay. Now, when I connect these, I remember that I need to connect them with a dotted line, so I'm going to just try my best to make this line nice and straight, since unfortunately there's no dotted line function in this graphing utility. And now I have to shade. Again, I'm shading on the bottom. So that is, again, just saying that all the points that satisfy this inequality are underneath the line. Okay, now shading on the bottom, I'm just going to make marks that indicate where the answers are. I don't actually have to like color in this whole area. And that would be the graph of that inequality. Okay, let's try one more. Okay, so same process here. We're going to again look at our y-intercept, we're going to look at our slope, and we're going to look at the inequality. Okay. So the inequality here, greater than or equal to, again, that's going to answer these questions right here. My slope is negative 3 over 4. So that means after I graph my y-intercept, I'm going down 3 because that 3 is negative. And I'm going right 4. Remember, rise over run. Down 3, right 4. My y-intercept is 5 on the y-axis, always starting on the y-axis. Okay, I'm looking at my inequality. I notice it has a or equals to underneath, so I'm going to graph a solid line. And then where do you shade? It says greater than or equal to. Greater than or equal to means I'm shading on the top. Okay, so solid line, and I'm shading on the top. Okay. Now, again, I'm going through all of this in my head. These are the decisions I make before I go to graph. So now we can graph. Okay, starting at positive 5. From that point, I go down 3, 1, 2, 3, and then I go right 4, 1, 2, 3, 4. Okay, I can repeat that one more time, going down 1, 2, 3, and then right 1, 2, 3, 4. Okay, now I'm going to connect those with a solid line because again, my inequalities is greater than or equal to. Okay, and now for shading, I'm going to shade on the top. So remember, the top, if you can't tell just by looking at the line, is the area of the graph that has the greater y values. So this is where I'm going to be shading. And that's it. Okay, so graphing linear inequalities, not too different from graphing regular y equals mx plus b. The two differences that you have to consider, both by looking at the inequality, are what does your line look like? Is your line part of the solution or not part of the solution? So that would be a dotted line. And then where do you shade, on the top or the bottom?